In this video, we go through packet classification topic outlined in the course of Switching Systems Architecture. The outline includes classification application, classification problems, after that it is hybrid classifiers, and a brief discussion about the partial matching classification. So, what is packet classification? Packet classification is an essential function to switches and routers that determine package output port, assign different services to classified packets, and is also used for usage recording. In SDN network, classification is essential to distinguish packets that belong to a flow. A packet classifier can also be used in traffic regulators, firewalls, and address translators. The performance of a classifier is valued by queue time and update time. Of course, shorter is better, but for update time, slow may also be acceptable. To classify a packet, at least one key from each packet is required, and the address information in packet header is always used for generating such keys. Generally, destination address is the most important, but the source address may be more relevant for filtering or recording usage. The problem about generating keys include key values might be correlated and timing issues. For example, for burst packets, the same key value would be queried for multiple times continuously. After matching a key of one packet, we would get a rule or several rules. For exact matching, all rules care about the same key digits, and at most one rule is matched for each packet. However, in partial matching, rules may care about different key digits, so multiple rules may also apply for the same packet. For example, there are two rules. The first rule, blocking traffic from network M. The second rule, forward traffic to network M through port P. So packet from M to M matches both rules, and we need to assign different priorities to these two rules. To find out the rule that maps to a key, we need to look up into a database. In practice, key can be created from multiple protocols. Such combining fields might lead to massive lookup tables. Parameters for database lookup include K, which is the key digital length, and D is the entry numbers, and E is the length of results. This is an example for creating a database lookup for classifying students. If we use students' ID number as the address, this is very simple and fast. The disadvantage is that it requires large random RAM. The second solution can be listing data in RAM. The plus side is that it would of course save a lot of space. The disadvantage is a time issue, no matter for sorted data, unsorted data, or even linked list data. Hashing seems to be an optimal solution. Hashing is an algorithm that maps large values to small values. The issue is that hashing collisions might be generated. That is to say, multiple large values may be mapped to the same hash value. So in the example of classifying students, hashing is that we use the last 3 digits of student's ID number as the hash value for indexing a table. When it comes to packet classification, the ASIC part of each packet is always treated as the hash value, and the beauty is that it requires no extra computation. In hardware layer, looking up a database is to access a piece of memory. It includes random access memory and a content addressable memory, which is also called CAM. In CAM scheme, words store labels and comparison logic, and it may also store data. The beauty of CAM scheme is that comparison operations are done in parallel, which would boost the throughput of a switch. A hybrid classifier is a combination of hashing scheme and CAM scheme. It tries hashing first, and collision hashing labels are all resolved in a CAM scheme. If a CAM is inconclusive, then use a tree that stores all the collision hashing labels. Partial matching classification can be achieved by ternary CAM scheme and trees. Ternary comparison is that for non-significant bits, it does not matter whether it is 0 or 1.
created using Powtoon.